This is College Algebra, Unit 4, Expressions, Equations, and Functions. Today we're talking about relations and functions in general, and then also we will talk about function notation and how to use it. A relation is a set of ordered pairs or points that can be shown in a graph, a mapping, a table, or expressed as an equation. In general, the domain of any relation is all the x values for all the points in the relation, and then the range is the set of all y values of all the points in the relation. Just recalling from some previous lessons, a discrete relation consists of a finite number of points, whereas a continuous relation connects those points, usually with a smooth curve or line. A function is a type of relation, so not all relations are functions, but all functions are relations, in which an element from the domain is paired with exactly one element in the range. So there can be one and only one y for every x. So we're taking a look at these two examples and determining whether or not it's a function. This one is a function, and we can say yes because there are no repeating x values. Whereas in the second example, 6 is repeated. So we say no because the x value 6 is repeated. Another way of determining whether or not a relation is a function is by using the vertical line test. So if, as I pass a vertical line over the graph, if the graph, or if the vertical line touches two or more points at the same time, such as in this second one, it touches 2 points at the same time, then it's not a function. But if it passes the vertical line text, it is a function. So this one's a function because as I pass the vertical line over the graph, I don't hit two x values at the same time. Whereas the circle is not a function because it doesn't pass the vertical line test. All right, so take a moment to look at 1 through 6 and determine whether each of these is a function or not. And then we're going to also identify the domain and range. So if we're looking at number 1, this is a function. The domain consists of the x values -2, 0, 2, 4, which we write in set notation. The range consists of the y values 6, 5, and 8. We're not going to repeat 6 because that's redundant. And again, we write this in set notation. We're going to do the same thing for number 2. All right, so I'm looking at the x values for each of these points. Okay, so I'm kind of looking at the axis to see where it lines up, and it looks like the domain is -3, and then, oh, excuse me, the domain goes this way, -3, -2, -1, 1, and 2, so we can see that it kind of lines up with the x-axis at those particular points. Let's see, that looks like, oh no, that's 2. Okay, and then the range lines up with the y-axis, so it looks like it goes, the y values for these points are -1, 0, 1, and 2. Okay, this is not a function because it doesn't pass the vertical line test. We can see that right here a vertical line would pass through these 2 points at the same time. Okay, sorry, this is difficult to see. These points are 3, 4, 0, 3, 3, and 1. Excuse me, it is not 4, it's a -1. They are difficult to see. This one is not a function. We can see this because there are 2 x values that are repeated, but it still has a domain and range. The domain is the 2 x values of 0 and 3, and then the range are the 3 y values, excuse me, of -1, 3, and 1. Okay. Number 4 is going to have a continuous domain and range. This is a function. It's a quadratic function, x squared plus 3. It's going to look like this. Okay, and we can see that it would indeed pass the vertical line test, so we could say, yes, this is a function. The domain, okay, it's going to get there slowly, but it eventually will get to -infinity. So since all real numbers are included, we're going to write our set in interval notation. It goes from -infinity to infinity. Our range, however, doesn't start at -infinity. It starts at 3. It includes 3, so we'll use brackets, and then it goes to +infinity. Number 5 is definitely not a function. This is a vertical line at -1. X equals -1. So we're going to say nope, not a function. Our domain is just -1. But our range, as you can see, the y values for every point on this line ranges from -infinity to infinity, or we could say all real numbers. Number 6, however, y is equal to 7 is a horizontal line. So it does pass the vertical line test. So we can say, yes, you are a function. The domain goes from -infinity to infinity, and the range is one number, 7. So the y value for every single point on this line is 7. So one number is the range. All right, we're going to kind of go into function notation and how to use it and what this means. Function notation is specifically used for finding some value in the range that corresponds to a certain domain value. Usually the functions are denoted by this following format. So we have f of x is equal to 5x plus 1. So we have some lowercase, usually a consonant, but it doesn't have to be. And then parentheses with x inside. And the way we would read this is f of x, indicating that this function is a function of x. And then we have g of x is equal to 1/2 x squared plus x minus 1. H of x is equal to the square root of x for all the x values greater than or equal to 0. The question arose in class, why does it matter that x is greater than or equal to 0. Well, that's only a condition for this particular function, because if you take the square root of a negative number, you get an imaginary number. So we're only going to deal with real numbers. Also, just a side note, although the functions that we'll be dealing with, at least in this particular section, usually deal with lowercase letters, with x in parentheses, they can also deal with uppercase letters. We've already encountered this when we talked about interest. Interest is a function of time, and we use the uppercase letter A or the uppercase letter I in order to denote that particular function. This function right here is a exponential function indicated. Also, this deals with interest on some future investment. So a capital S is equal to P, where P is the principal investment, and then E raised to the power of RT, where R is the rate and T is time. So the functions above, right here, of the independent variable are a function of the independent variable x. So to evaluate them, we say we plug in an x value from the domain and then solve the equation for that value and arrive at the corresponding value of the range. So you can see here there's a couple of ways that we could go about solving or evaluating these functions. First of all, we need to make sure that we're using the function that's corresponding. So we're dealing with f of x, g of x, and h of x. And then we're going to plug in the x values that are in the parentheses. So we have f of -1/5 is equal to 5. And every time we see x, we're going to plug in -1/5 into that x value. So there's an x here, so we're going to plug in -1/5 there. All right, so doing it this way, we can say, you could just do it in your mind and realize that the answer is going to be 0, but then at the same time, you can use your calculator and get 0. Okay? Now, we have several functions here, or we have several problems that are using the same 3 functions. So another way we can do this is we can enter this function 5x plus 1 into y1. We can enter 1/2 x squared plus x minus 1. So this is g of x is going to be into y2. And then h of x, the square root. Okay, square root is second. It takes second to fire the function. And then you push the button x squared and then x. Okay, so when we graph these functions, then we can identify or plug in x values and make the calculator find the corresponding y values using a value function. So if I were to do number 1, I want to hit second calc value, and I want to plug in -1/5 in for x, and I can see that for y1, -1/5, or f of -1/5 is equal to 0. Okay, now I have to make sure I'm on the right function. I push the up and down buttons, and now I'm on the quadratic function. Then if I push the down button again, I'm on the radical function. So here I am back on the linear function, and let's say now I want to find g of 2. Okay, so what that means is I want to plug in 2 every time I see an x in the g function. So I have 1/2 2 squared plus 2 minus 1. Well, I can hit second calc value 2, okay? However, you can see up here, I'm in y1. So I want to be in y2, which is my g of x function, and I see that g of 2 is equal to 3. Okay, so just take a moment to complete the rest of this page. I would suggest pausing the video and going ahead and checking these answers. Okay, for number 3, you should get 6. For number 4, you would get 3. Number 5, you would get 0.5 or 1/2. And then for number 6, you would get 3. Okay. For number 7, I get 2.25 or 2 1/4. And then for number 8, the way you would enter this is second calc value, and then the pi button is right here. So then we'll hit second and this button to fire the pi. Okay, but I don't want to be in f of x, I want to be in g of x, which is my red. So I get the answer g of pi is equal to 7.07639949, blah, blah, blah. It's an irrational number. Okay, the next page is pure practice. So please take a moment to complete the entire next page. One thing I do want to draw to your attention is when you have something like number 12, and you have a binomial that you're plugging in for a. So this is w of a plus 4. Then I'm going to plug in a plus 4 every time I see a. Then I add the 3. So then this would be a plus 7, and that's my final answer. Then for number 14, you're going to plug in 4 plus t every time you see t. So h of 4 plus t is equal to 2 times 3 raised to the power of 4 plus t plus 3. Now you absolutely cannot multiply together the 2 and the 3. Do not do that because they don't have the same exponent. That would be like saying I can multiply together this and get one answer. You can't do that. You just can't do that. So you have to leave it separate. So 2 times 3 raised to the power of t plus 7. Kind of the same thing you want to think about for number 13. P of x minus 4 means that every time I see a, I'm going to plug in x minus 4. Okay? And then I'm going to subtract 5. Well, x minus 4 squared is the same thing as saying x minus 4 times x minus 4. So this isn't simply x squared minus 16. You have to FOIL it. So this is x squared plus 8x plus 16 minus 5, which in the end, combining like terms, you get x squared plus 8x plus 11. Okay, so I encourage you to continue to work this whole page and then scan the QR code and it will give you the answers.